Electricity, grade 10 physics. So in this topic, we will discuss about electric current, electric charge, electric current and electric charge, potential difference, electrical potential. So everything we'll discuss. Hello, hi everyone. Welcome to the Student Brand. This is Varsva sir. Today in this topic, so we'll discuss about electrical electric current, that is nothing but CBSE grade 10 physics, CBSE grade 10 physics. So in this topic we'll completely work out, we purely work out on how the charges are there, okay. So how the charges are there, charges, electric current, quantization of charge, and next one electric circuit will discuss, electric circuit and potential difference, electric circuit, potential difference, electrical potential, and next one after that Ohm's law, and resistance, factor depends on resistance, resistivity, we'll discuss on resistivity, okay. So resistance and resistivity, the factor depends on resistance and resistivity, Next one, we are going to the resistors are in series, resistors are in parallel, resistors are in series, resistors are in parallel. Next one, after resistors are in series, resistors are in parallel, we will discuss about heating effect of electric current. So based on that one we will discuss. So these are very, very important points. So whatever we are discussing now, once again, so those points I'll write, what are the points are we are going to discuss. Now you can see electric current. So electric current, electric current is nothing but the rate of flow of charge. Electric current is nothing but the rate of flow of charge. The flow of charge. Okay, so I equal to Q by T. So I'm considering I equal to Q by T. So I is a current. SI unit of current is ampere. So ampere I'm considering. And SI unit of charge is coulomb. And SI unit of time is second. So I equal to Q by T. I'm considering I equal to Q by T. So I equal to Q by T. SI unit of current is ampere. SI unit of charge is coulomb. SI unit of time is second. So now our 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per 1 second. So SI unit of current is ampere, I said. SI unit of charge is coulomb. SI unit of current is ampere. SI unit of charge is coulomb, and SI unit of time is second. So the rate of flow of charge, is called electric current. Okay. So one more definition: the flow of charge through unit cross section area. The flow of charge through unit cross section area per second. Is called electric current. The flow of charge through unit cross section area per second is called electric current. So I'm considering here, I'm taking this conductor. So this is a conductor. So the charge is moving through this conductor. Like this. So this area of the cross section. The current is passing through it. So charges are moving like this. So then we can take, so area of the cross section. the flow of charge through unit cross section area, the flow of charge through unit cross section area per second is called electric current. I equal to Q by T. So I equal to Q by T. I'm considering I equal to Q by T. So we can see SI unit of the current is ampere, SI unit of charge is coulomb, SI unit of charge is coulomb, and SI unit of time is second. So that is nothing but I equal to Q by T. So 1 ampere and 1 coulomb 1 per second. This is about current, and here we can see charges. So charge, if you take, there are types of charges. So types of charges. So quantization of charge, quantization of charge. So here charge is a property of the matter. So charge is a property of the matter which influence the presence of other charge. Charge is a property of the matter which influence the presence of other charges. There are two types of charges are there. Positive charge and negative charge. So two types of charge. So positive charge and negative charge. So positive charge and negative charge. So positive charge will attract. Positive charge and positive charge will attract. And negative charge will repel. Negative charge will repel. So positive charge will attract. Negative charge will repel. Okay, so will repel. And I'm considering here. So quantization of charge is nothing but, so charge is inside of the conductor if you are taking. So if only one conductor will move, we can't say charge is passing. So there are number of so many number. So number of charges will move inside of the conductor. Then only we can say current is flowing. So that's why Q equal to plus or minus Ne. Q equal to plus or minus Ne. So I equal to Q by T. So I equal to Ne by T. So I equal to Ne by T. So very, very important. So Q equal to plus or minus Ne, that is nothing but charge. I equal to Q by T. I equal to Ne by T. So now you are considering, so Ne, we can say charge of an electron. So on one electron, how much charge is present? On one electron, so 1.6 into 10 power minus 19 coulomb. So on one electron, how much charge is present? 1.6 into 10 power minus 19 coulomb. So if you are taking on in 1 coulomb, how many electrons are present? So 1 by 1.6 into 10 power minus 19. So if you are taking 1 by 1.6 into 10 power 19. So if you do it 1 by 1.6 into 10 by 10. So into 10 by 10, if you are taking 10 by 19. So if you are solving 10 by 16, so into 10 power 19. If you do this, you will get 0.625 into 10 power 19. So if you solve still this one, so you'll get the answer. 6.25 into 10 power 18 electrons. So 10 power 18 electrons. So in 1 coulomb, this many electrons are present. So very, very important. Keep in mind. This one is very important. In 1 electron, how much charge is present? On 1 electron, how much charge is present? That is 1.6 into 10 power minus 19 coulomb. So in 1 coulomb, how many electrons are present? That is 0.625 into 10 power 19. So we'll get 6.25 into 10 power 18 electrons. So that is about in 1 coulomb. So this many electrons are present. So that is a quantity. That is about so on one electron, how much charge is present? In 1 coulomb, how many electrons are present? So that's enough. So very, very important. Make a note of it. And coming to the next one. Next one is about. So we'll go to the electrical appliances. So if you know the electrical appliance, automatically I will explain about electric circuit. I can explain. See, if you know the electrical appliances, what are their electrical appliances? Positive, negative. So now I am considering. So this is the cell. So I am taking this is cell. So positive terminal, negative terminal. First one is cell. Second one is battery. So second one is battery. So positive, negative. So battery I am taking. Battery. So battery, this is a battery. And third one, if you are considering switch. This is the open switch, and coming to the fourth one, closed switch. This is a closed switch. I'm considering closed switch, closed switch, closed switch, closed switch, and fifth one you can consider bulb. This is the bulb symbol. This is a glowing, this is glowing. Okay, so bulb are considering, and sixth one if you are taking a resistor, this is the resistor I'm considering resistor. Okay, so this is about a resistor. So I'm considering this a resistor, and the next one, seventh one is a rheostat. This is the rheostat. I'm considering this rheostat. So here we can draw like this also, and we can draw like this also. Anything rheostat. I hope it is very clear. Once again, so you can check once. Once again, you can check once here. So cell, battery. So cell, battery, open switch, close switch, bulb, resistor, and rheostat. Next one we'll discuss about ammeter. So this is ammeter. I'm taking here. This ammeter, positive terminal, negative terminal, and the next one voltmeter. So this is a voltmeter. And next one galvanometer. So galvanometer is okay. Wire joining. This is a wire joining. And next one wire crossing. This is a wire crossing. Hi sir. Nice dress. Thank you. So this is a fourth one. Wire joining. This is a wire joining. This is wire joining, and this one is wire crossing. And next one, if you are going to, so these are the electrical appliances. So next one, we are going to the electrical circuit. I'll explain. A closed and continuous path of an electric current. A closed and continuous path of an electric is called electric circuit. A closed electric circuit. So electric circuit. A closed and continuous path of an electric current is called electric circuit. A closed and continuous path of an electric current is called electric circuit. A closed and continuous path of an electric current is called electric circuit. A closed and continuous path of an electric current is called electric circuit. A closed and continuous path of an electric current is called electric circuit. A closed and continuous path of an electric current is called electric circuit. A closed and continuous path of an electric current is called electric circuit. Hi, Hanad. So, hi. So, that is about electric circuit. Next one. So, here I am considering in electric current. So, electric current, there are two types are there. Two types of electric current. Like, so electric circuit, if you are taking, so this is a positive I am considering. So, battery here. This is a battery. So from here, ammeter I am taking, this ammeter, and next one here bulb. This is the bulb. So this is the bulb, and switch I am considering here. So here is positive terminal, positive, negative. Current is flowing like this. So this is the positive terminal, negative terminal, bulb. So glowing bulb I am taking here. Okay, so here you can observe. conventional current and electric current, conventional current and electric current. Second one is electric current, electric current, electric current, electric current. So conventional current is nothing but conventional current is nothing but conventional current. So the flow of positive charges is called conventional current. Normally you see, so before finding electron, proton, all these things, so scientists were given the statement. So the positive charges, so the direction of flow of positive charges, will be considered as a current. The direction of flow of positive charges is called current. The direction of flow of positive charges is called current. Okay, so like that they given. So we are taking the direction of flow of positive charges only, the direction of the current. The direction of the flow of positive charges only, direction of the current. The direction of the flow of positive charges is only the direction of the current. So before finding electron, proton, like that. So already given the statement. So that's why we are following still that only. So that instead of changing the statement, instead of changing the experiments, all their hard work, so better we do change the statement. So that is conventional current. We will make it as a conventional current. Now we are going to the electric current. So after they found flow of electrons, because of the electrons movement only, current is passing. So because of that reason, so they mentioned the electric current. So conventional current is nothing but flow of positive charges. Electric current is nothing but flow of negative charges. So here one more point you need to understand. So that is the positive charge have high potential, negative charge have low potential. Positive charge have high potential. So positive charge has high potential, negative charge has low potential. So positive charges will move from positive terminal to negative terminal, whereas electron will move from negative terminal, that is nothing but low potential to high potential, So that is about conventional current and electric current. So next we are going to the next one, electrical potential. So electric circuit is nothing but a closed and continuous path of an electric current is nothing but electric circuit. A closed and continuous path of an electric current is known as electric circuit. A closed and continuous path of an electric current is known as electric circuit. Next one, potential difference. So we are going to the potential difference. So potential difference. So if you are taking the potential difference, I'm considering potential difference is nothing but so here we are taking conductor, within the conductor. So this is a positive charge. We are doing some work. So to bring from point A to point B. So here you can see we are doing some work to bring the positive charge. From point A to point B. So from point A to point B. So we are doing some work to bring the positive charge from point A to point B. That is called a potential difference. So V equal to W by Q. So we are doing some work to bring the unit positive charge. So we are doing some work to bring unit positive charge from point A to point B. We are doing some work to bring the positive charge from point A to point B. Within the conductor. That is nothing but potential difference. So SI unit of potential difference is volt. SI unit of potential difference is volt. SI unit of work is joule. SI unit of work is joule. I am taking. So SI unit of charge is coulomb. So that is nothing but 1 volt equal to 1 joule by 1 coulomb. So 1 volt equal to 1 volt equal to 1 volt equal to 1 joule by 1 joule of work is done to bring 1 coulomb of charge. So 1 volt is defined as 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge from one point to another point. So potential difference is nothing but 1 joule of work is done to bring 1 joule of work is done to bring 1 joule of work is done to bring 1 coulomb of charge. One joule of work is done to bring 1 coulomb of charge from point A to point B. From point A to point B. 1 joule of work is done to bring 1 coulomb of charge from point A to point B. 1 joule of work is done to bring 1 coulomb of charge from point A to point B. 1 joule of work is done to bring 1 coulomb of charge from point A to point B. 1 joule of work is done to bring 1 coulomb of charge from point A to point B. 1 joule of work is done to bring 1 coulomb of charge from point A to point B. 1 joule of work is done to bring 1 coulomb of charge from point A to point B. That is nothing but so 1 volt, 1 volt. So 1 volt equal to 1 joule by 1 coulomb. And so now I am considering the electrical potential, electrical potential. So electrical potential is nothing but work done to bring. So here you am considering here like this. So this the infinity. So positive charge is there. So this is the required field. This is the required field. So we are doing some work. We are doing some work to bring the unit positive charge from infinity to the required field. From infinity to required field. So infinity to the required field. So that is nothing but so we are doing some work to bring a unit positive charge from infinity to the required field. Infinity to the required field, that is nothing but electrical potential. Whereas potential difference work done to bring unit positive charge from one point to another point. One point to another point. That is about potential difference and electrical potential. So next we are moving on to the next topic. Ohm's law. So Ohm's law I will explain. Ohm's law. So I'll explain Ohm's law. So be careful. So listen carefully. This topic is very important. Ohm's law. So Ohm's law. So the potential difference across a metallic conductor. So I'm taking this resistor. So I'm considering here ammeter. I'm considering like this. So here batteries. So 1, 2, 3, 4. So there are 4 cells, and here I'm considering like this. So positive terminal to negative terminal, like this it's passing. Here is a positive terminal to negative terminal, and here I'm considering, here. So here you can see. Okay, so so positive terminal, negative terminal. So each point is 1.5, 1.5, 1.5, 1.5. So there are 4 cells. So statement. What is statement? Statement is nothing but the potential difference across a metallic conductor. So the potential difference across the ends of the metallic conductor is directly proportional to current flowing through it. At constant temperature. The potential difference across the metallic conductor. The potential difference across the ends of the metallic conductor. Is directly proportional to current flowing through it. The potential difference across the ends of the metallic conductor. Hi Danishka, welcome to the class. So the potential difference across the ends of the metallic conductor is directly proportional to current flowing through it. So V is directly proportional to V equal to IR. So here I am taking, so it gives the relation, it gives the definition of Ohm's law gives the definition of resistance. Ohm's law gives the definition of resistance. V equal to IR. So the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. So V is directly proportional to V equal to IR. So next one, materials required. So what are the materials required? So now we will see materials required. So materials required. I am considering the materials required. So first one we need four cells. We need four cells. Here you can consider first point is so four cells of 1.5 volts each. Four cells of 1.5 volts. So here you can see. So 1, 2, 3, 4. So 1.5 volts each. How many cells are required? Four cells. And second thing, nichrome wire. Nichrome wire we have to take. Nichrome wire. Nichrome wire is an alloy of so 0.5 meter. 0.5 meter. And third one, switch. So we can go for a switch. And fourth one, voltmeter. And fifth one, ammeter. And sixth one, connecting wires. So cells, nichrome wire, voltmeter, ammeter, switch. Next one, connecting wires. So these are the materials required. These are the materials required. So here, so now once again, so the statement, if you are coming to the statement, the potential difference across the ends of the given metallic wire. So the potential difference across the ends of the given metallic wire is directly proportional to current flowing through it. V is directly proportional to V is directly proportional to V equal to IR. So at constant temperature, the potential difference across the ends of the metallic conductor is directly proportional to current flowing through it. V is directly proportional to V equal to IR. So coming to the materials required. So four cells 1.5 volts each, nichrome wire 0.5 meter, and switch, a voltmeter, ammeter, and connecting wire. So these are the materials required. Next one, coming to the procedure. So coming to the procedure. So procedure is nothing but first you have to connect one cell. So one cell, connect one cell, and note down the reading of ammeter and voltmeter. First connect one cell. So that is the reason you can observe here we did the dotted line. So we mentioned the dotted line because so one by one we are connecting. That's why we are mentioning. So that's why we are mentioning dotted line. So one by one you have to connect one cell and note down the reading of ammeter and voltmeter, and connect connect two cells and note down the reading of ammeter and voltmeter, and repeat the process for 3 and 4. So repeat the process for 3 and 4 cells. Once again, here, so procedure is nothing but you must connect one cell first. And note down the reading of ammeter and voltmeter. Next one, we have to connect two cells. Next to two cells you have to connect and note down the reading of again ammeter and voltmeter, and repeat the same process for 3 and 4. Repeat the same process for 3 and 4. Then so we can see this is about procedure for Ohm's law. Next one, if you draw the what are you got, right? So after noting the ammeter and voltmeter readings, you have to mention in the tabular form. After that, after noting down, so after observing, so you mention in the tabular form. You have to mention the tabular form. So now if you draw the tabular form, so I am taking the tabular form. So this is the tabular form. How here you can consider. Okay, so I'm considering serial number of cells, ammeter, voltmeter, V by I form. So you have to consider 1, 2, 3, 4, and here like this. So serial number, number of cells, and ammeter, voltmeter, V by I. So normally V equal to IR. So V equal to IR, right? I equal to R equal to V by So R equal to V by. So that is nothing but, so we are taking R value. So here I am taking the R value. So 1, 2, 3, 4. So we have to take 4 cells. Sir, R is constant for a proportionality. Then how it varies after changes voltage and current? that's why it is right. Every time it is constant only, right? That's why we are taking. So every time you are taking 1, 2, 3. So number of cells 1, 2, 3. So every time you are taking the values. So here whatever value, the R value is constant only. R value is constant only. R won't change. No, I didn't say. So R is constant only. See, whenever we are taking this a proportionality constant, correct only. That's why V by value. So according to the V by value, so R is same. What are the values? You consider if you draw the graph. If you draw the graph, okay, so the graph will be linear. Okay. So different values R will be different, right? So like a constant only. R will be constant. What are the values you consider? So here, so whatever value you are getting, R value will be constant. Okay. That's the reason why even V and I keep on changes. So it will be constant. That's why it is linear starting from origin. Clear? What is your name? Kunal. Is it clear? Kunal? Do you have any doubts? Yeah, correct only. See, when the current is we are taking according to if you draw this one. So I will do one problem related to this one. I'll do one problem. So I'll show you. So I'll show you R is constant only. Every time you take the values and do you'll get constant values. You'll get constant values. No changes. Current and potential difference by value. Okay. So we'll do while doing problems, we'll get it. Next one, so we are going to the next one. Okay, so I'll give one problem related to R. So I'll show you. Actually, we did problem. Samir Agarwal, sir, what is this dress? This dress is design, teaching aids. So in the once you check my YouTube channel, you'll get it. There are many experiments. So this is one of my experiment. So teaching physics. Okay. So he asked that Kunal. So I'll draw here. You can see this is the table. So this is the question. This is completely question. You can check here. I hope it is visible to you. Okay. So now I'm taking. Number of values. So V and I 0.5, 0.2, 1.0, 0.4 and 1.5, 0.6, 2.0, 0.8 and 2.5, 1.0. So every time we have to take the values here. So the R value is V2 minus V1. R2 value is normally slope. Slope you are considering it. Slope you are taking. Slope you are considering. Slope is, so slope here you can see V equal to IR. V equal to IR. So R equal to V by I. R equal to V by I. That is what V2 minus V1 by I2 minus I1. Normally in maths, you know, right? Slope of graph, if you are taking x2, y2 minus y1 by x2 minus x1. So if you are taking this graph, so this is y-axis, this is x-axis. So I am taking y2 minus y1 by x2 minus x1. So see the same format. So we are taking the R value. So R value are considering R is C. We have to take on y-axis first. Y-axis we are taking V. X-axis we are taking I. So first we have to take V value. So V value I am taking this value and this value. Next one by one after another consecutive values I am taking here. So you can consider 1 minus 0.5 by, so 0.4 minus 0.2. So you are considering R, right? So 0.5 by, here I am considering 0.2. So 10 by 10. Then we will get 5 by 2, that is nothing but 2.5. So 2.5. So next one more values also you can consider. One more value I am taking. So here you can see. one example. So I will take this and this. You can take 2 minus 1.5 by 0.8 minus 0.6. So 0.5 I hope. So 0.2. Same 10 by 10. You'll get 5 by 2. That is nothing but 2.5. And one more value also I'll do. One more value also I'll do. So I can consider, I can take, you can consider this and this also. Like 2 minus 1 by 0.8 minus 0.4. So here how much? 1. Here how much? 0.4. So 10 by 10. So 10 by 4. So 2.5. So 4 2 ja, right? 4 2 ja 2 8 2 0.5 20. Correct? Any value you take, any value you take, Kunal. So you can take any value. R is constant only. So this type of problems they will ask in the exam. Try to do it. So I hope it is clear to you. Your doubt. Next one, coming to the Ohm's law completed. Ohm's law completed. Next one we are going to the factor depends on resistance. Factor depends on resistance. Resistance. Factor depends on resistance. Factors depends on resistance. Resistance. Factor depends on resistance. So here R is resistance. R is resistance. R is nothing but resistance. So R you are considering resistance is nothing but the phenomena of opposing the electric current. The phenomena of opposing the electric current. So the phenomena of opposing the electric current is nothing but resistance. SI unit of resistance is ohm. SI unit of resistance is ohm. So we can take resistor. SI unit of resistance is ohm. SI unit of resistance is ohm. Now I am considering resistance is depends on length of the conductor. Resistance is depends on length of the conductor. Resistance depends on area of the cross section. Resistance depends on length of the conductor. Resistance depends on area of the conductor. So R is directly proportional to L by A. So R equal to rho into L by A. So R equal to rho into L by A. R equal to rho into L by A. So I am considering here R equal to rho into L by A. So rho equal to RA by L. Rho equal to RA by L. Rho equal to RA by L. Hi multiplier. Welcome to the class. So I equal to rho equal to RA by L. Rho equal to RA by L. So once again, R is directly proportional to length of the conductor. R is inversely proportional to area of the conductor. So we can say R is directly proportional to L by A. R equal to rho into L by A. So rho equal to RA by L. So here rho is a resistivity. R is a resistance. R is a resistance. Resistance, and rho is the resistivity. Rho is the resistivity. So here you can consider R. So difference also very important. Now you can consider, we need to find out SI unit of resistivity. SI unit. So SI unit I will direct, just check it once. So rho equal to, they will ask for 2 marks also this question, RA by L. So they will ask for 2 marks. This question they will ask for 2 marks. So now you can check. So ohm meter square by meter. So meter get cancelled, then ohm meter. So ohm meter, resistivity equal to ohm meter. So here you can see this question is very important. For 2 marks question, definitely this question will come for 2 marks. And difference between resistance and resistivity also. Difference between resistance and resistivity also they will ask. Difference between resistance and resistivity they will ask. And SI unit of resistivity. SI unit of resistivity also they will ask. SI unit of resistivity. So keep in mind this question. So once again, factor depends on resistance. These questions they will ask. and resistance depends on R is the resistance, rho is the resistivity. Resistance depends on length of the conductor, resistance depends on area of the conductor. So resistance equal to directly proportional to L by A, R equal to rho into L by A, rho equal to RA by L, rho equal to RA by L. So rho is the resistivity, R is the resistance. SI unit of resistivity, SI unit of resistivity is, if you want to identify SI unit of resistivity, so rho equal to ohm meter, rho equal to ohm meter, very very important. So 2 marks question, so this question will come for so 2 marks question definitely. So this question for MCQs, for MCQs point of view are important. Difference between resistance and resistivity, so they will ask for 3 marks also, they will ask for 3 marks. So this they will ask for 3 marks, and this one also they will ask for 3 marks. So 3 marks once again. So resistance and so factor depends on resistance. So resistance depends on length of the conductor, resistance depends on area of the conductor. So R is directly proportional to L by R equal to rho into L by A, rho equal to RA by L. So here SI unit of resistivity. So we are finding SI unit of resistivity, SI unit of resistivity, SI unit of resistivity. Very very important. Make sure that you are learning this one. And here you can see resistance and resistivity. Resistance. I will explain these points. I will explain. Just you can see. Factor depends on resistance and resistivity. Resistance. Resistance. I am taking here one side. Resistance. And resistivity. Resistivity. Resistance and resistivity. Now you see. So the formula of resistance. The formula of resistance is R equal to rho into L by A. R equal to rho into L by A. So next one. Second one. So R is directly R depends on length and area. So second one. And third one, SI unit of resistance is ohm. SI unit of resistance is ohm symbol. And next one, fourth one, resistance depends on temperature. Resistance depends on temperature. And fifth one, resistance depends on material also. Material. Okay, once again, so you can check resistivity. Resistivity does not, resistivity formula. First one, rho equal to RA by L. Rho equal to RA by L. Second one, so does not depend on L and area, length and area. So third one, ohm meter, that is ohm meter. So symbol is very very important in problems they will ask. So ohm meter, they will ask about ohm meter. So you can see ohm meter. And next one, fourth one, depends on temperature also. It depends on temperature. And fifth one, so it depends on material also. So very very important for 3 marks question. This question will come for 3 marks. So that much important 3 marks question. So practice and prepare, learn. So all these points, definitely they will ask about the difference between resistance and resistivity. Difference between resistance and resistivity. So 3 marks question. 3 marks question. So practice this question 3 marks. Okay. So 3 marks. Okay, this question for 3 marks. Okay, so make sure that you are learning this one. Once again, I will explain. So listen carefully. Once again, I will explain. So resistance is equal to resistance is a phenomena of opposing the electric current. Resistance is nothing but phenomena of opposing the electric current. The resistance is nothing but phenomena of opposing the electric current. Resistance is nothing but phenomena of opposing the electric current. Resistance is nothing but phenomena of opposing electric current. Resistance is nothing but phenomena of opposing the electric current. Resistance is nothing but phenomena of opposing the electric current. Resistance is nothing but phenomena of opposing the electric current. So SI unit of resistance is ohm. Which device is used to identify the resistance? Which device is used to oppose the electric current? Which device is used to oppose the electric current in the circuit? So resistor. Resistor is a device which is connected in the circuit to oppose the electric current in. Sorry. So resistance. So R is equal to rho into L by A. Resistance depends on length and area. So this also we can say physical dimension. So resistance depends on length and area. Resistance depends on length and area. And also SI unit of resistance is ohm. SI unit of resistance is ohm. SI unit of resistance is ohm. So your resistance depends on temperature. Resistance depends on temperature. Resistance also depends on material of the conductor. Coming to the resistivity, resistivity is nothing but resistance of the conductor of unit length and unit cross section area. Generally, this formula they will ask for 2 marks or 1 mark. Okay, so like this, if you divide in this way, so you can identify resistance of the conductor per unit length and unit cross section area. Resistance of the conductor per unit length and unit cross section area. Resistance of the conductor per unit length and unit cross section area is nothing but resistivity. So resistivity does not depend on length and area. Resistivity does not depend on length and area. Resistivity does not depend on length and area. So SI unit of resistivity is ohm meter. SI unit of resistivity is ohm meter. SI unit of resistivity is ohm meter. So resistivity depends on temperature. Resistivity depends on material of the conductor. Once again, resistance is nothing but phenomena of opposing the electric current. Resistance depends on length and area. SI unit of resistance is ohm. Resistance depends on temperature. Resistance depends on material. So resistivity, resistance of the conductor per unit length and unit cross section area, that is nothing but resistivity. Hi Praveen. So Pavan, okay. So the resistivity does not depend on length and area. So SI unit of resistivity is ohm meter. So resistivity depends on temperature. Resistivity depends also on material of the conductor. So this is about okay. So difference between resistance and resistivity. Difference between resistance and resistivity. So next one we are going to one more point. So we'll go for resistors are connected in series combination. Resistors connected in parallel combination. We'll discuss that one. Resistors are connected in series combination. Resistors are connected in parallel combination. So we'll work out on it. Just check once. Resistors are connected in series combination. Resistors are connected in parallel combination. Resistors are connected in series combination. Resistors are connected in series combination. Okay. Like this we can consider now. So I'm taking here you can see one resistor, another resistor and another resistor. So I'm taking ammeter. So battery. So here switch. Positive terminal, negative terminal. Current is passing. So this is the key. So positive terminal, negative terminal. Across this one voltmeter we have to connect. Voltmeter. R1, R2, R3. Okay, so now you can observe this condition. So throughout the circuit current is same. Current is same in the throughout circuit. So I am taking here. Okay. So from Ohm's law V equal to IR. 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 From Ohm's law V equal to IR, right? So we can take from that. We know. So if you are taking from that, so if you are considering from that, okay. So now you can check. Now you can check. So Vs. So total potential difference is equal to V1 plus V2 plus V3. V1 plus V2 plus V3. So IRS equal to IR1 plus IR2, IR2 plus IR3. So we am taking I common. I am taking common. So if you are taking I common, R1 plus R2 plus R3. So RR get cancelled. So we can cancel R value. So if you cancel R value here, sorry, I value can cancel. So I is common, right? I is cancelled. So the remaining values are RS equal to R1 plus R2 plus R3. R1 equal to R2 plus R3. So very important. So this expression for resistors are connected in series combination. Expression for resistors are connected in series combination. So this question will come for 3 marks. This question will come for 3 marks. Very important. So expected question and derivation. So 3 marks. So 3 marks will come. So 3 marks question. 3 marks question. So 3 marks question, this one, 3 marks question. Okay, so expected for a board exam. And this derivation also. Total resistance is equal to R1 plus R2 plus R3. So if you are taking, if n number of resistors are connected in series combination, if n number of resistors are connected in series combination, if n number of resistors are connected in series combination, if n number of resistors are connected in series combination, Rs equal to Nr. If n number of resistors are connected in series combination, Rs equal to Nr. Rs equal to Nr. Okay. Thank you so much. That's enough. So that is about resistors are connected in series combination. So now I am going for resistors are connected in parallel combination. 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 So I'm considering now. So resistors are in parallel combination. You can observe here. So I'm taking one resistor and another resistor. The third one. So here I'm considering like this. So here is ammeter and battery. So here you can see current is passing. So here a voltmeter, I'm connecting voltmeter. So this is the R1, R2, R3. So positive, negative. So whatever the current is flowing here, that is dividing into 3 parts, I1, I2, I3. So here you can observe whatever the current is flowing here, that current is dividing into 3 parts, I1, I2, I3. So I1, I2, so you can see here I1, I2, I3. So current is passing here. So from Ohm's law, V equal to IR, I equal to V by R. Because current in parallel combination, because potential difference across 3 resistors is same. So then we can say, now I'm considering V by RS, V by RP equal to V by, so that is nothing but current we can consider. Instead of taking this one, before that we have to take IP equal to I1 plus I2 plus I3. So current in parallel combination. Then from here, from this relation, V by Rp equal to V by R1 plus V by R2 plus V by R3. So V by R1 equal to, so V by R2 plus V by R3. Ohm's law, what is Ohm's law? So Ohm's law, it's not about Ohm's law, so it is about Ohm's law. It is a law. Ohm's law is nothing but at a constant temperature, at a constant temperature, the potential difference across a given metallic conductor is directly proportional to current flowing through it. Once again, so at a constant temperature, the potential difference across a given metallic conductor is directly proportional to current flowing through it. Okay, so if the potential difference across a metallic conductor is directly proportional to current flowing through, so that is nothing but Ohm's law. Okay, so next, what is your name? Can I know your name? And here, okay, so IP equal to I1, I2, I3. So V by Rp equal to, we can take V by 1 by Rp equal to, so V we are taking common 1 by R1 plus 1 by R2 plus 1 by R3. So now you can take VB get cancelled, VB get cancelled. 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. So every day you have a live class. Every day live class. Every day. So every day live class at the rate of 9 p.m. in student the brand. So I hope it is clear. Just check once. Okay, next one. So this is about resistors are in parallel combination. Now you are getting. So this is the formula. This is the formula. Okay. So now, if n number of resistors are connected, if n number of resistors are connected, 1 by Rp equal to n by R, n by R, Rp equal to R by n. If n number of resistors are connected, if n number of resistors are connected, 1 by Rp equal to n by R, so Rp equal to R by n, right? So very, very important derivation. So this also they will ask for 3 marks. And which physical quantity is constant in 3 marks? Three marks question. And even this they will ask for 1 mark also. This one 1 mark. And this one 1 mark. And this one, so this they will ask for 2 marks. 2 marks question. 2 marks. Anyway, Ohm's law 1 mark. 1 mark. Okay. So make sure that you are learning all these points. So this 3 marks, entire derivation, entire expression. So not only circuit diagram, including derivation, they will ask for 3 marks. And this current is current IP equal to I1 plus I2 plus I3, and potential difference is constant. Potential difference is constant, right? So that's why potential difference also Vp equal to V1 equal to V2 equal to V3 equal to V. So potential difference is constant in parallel combination. So across all 3 resistors, we connected only one voltmeter. So that is the reason potential difference is constant. That is the reason we are connecting. So very, very important concept. These points they will ask for 1 mark, and this point also they will ask for 1 mark. This point also they will ask for 1 mark, and this one they will ask for 2 marks, and this one they will ask for 1 mark. So this is about resistors are connected in series combination. Resistors are connected in parallel combination. So if you have any doubts, you can ask. Otherwise, I'll go to the heating effect of electric current. The source of energy continuously gets dissipated entirely in the form of heat. The source of energy continuously gets dissipated entirely in the form of heat. That is nothing but a heating effect of electric current. So the source of energy continuously gets dissipated. The source of energy continuously gets dissipated entirely in the form of the source of energy continuously gets dissipated entirely in the form of heat. The source of energy continuously gets dissipated entirely in the form of heat. The source of energy continuously gets dissipated entirely in the form of heat is called heating effect of electric current. So here you can consider V equal to so heating effect of electric current. Electric current, heating effect of electric current. So now I am considering, so V equal to W by Q, V equal to W by Q, that is nothing but potential difference. Potential difference equal to work done on unit positive charge to bring from one point to another point. So from this, W equal to VQ, W equal to VQ. So the rate of doing work is called power. Rate of doing work is called power. So VQ by T. So there is nothing but V into Q by T. So Q by T is nothing but I. So generally we can say Q by T. Q by T is I. Q by T is I. So rate of flow of charge. Rate of flow of charge. So in this we are substituting I value. Now you can check. So P equal to VI. P equal to VI. So energy is nothing but P into T. Energy is nothing but P into T. Energy is nothing but P into T. So we can take, so in the place of P, we can substitute this value. In the place of P, we can substitute VI. Whatever the energy is given to the conductor, that will become in the form of heat. So heat H equal to, so V equal to IR. V equal to IR. So in the place of V, so I'll substitute IR. Now you can see IR into I into T. So H equal to I square RT. Heat produced in the conductor is directly proportional to square of current. Heat produced in the conductor is directly proportional to square of current. Heat produced in the conductor is directly proportional to resistance. Heat produced in the conductor is directly proportional to time. So these are the point. Once again, heat is directly proportional to square of current. Heat is directly proportional to resistance. Heat is directly proportional to time. So this is enough. Okay, so that is about heating effect of electric current. Heating effect of electric current is also known as Joule's law of heating. Heating effect of electric current is also known as Joule's law of heating. Heating effect of electric current is also known as Joule's law of heating. Heating effect of electric current is also known as Joule's law of heating. Heating effect of electric current is also known as Joule's law of heating. So make sure that you are identifying this one. So applications of heating effect of electric current. Applications of heating effect of electric current. So electrical cooker, electrical oven, and iron box, room heaters. These are the applications of heating effect of electric current. I hope it is clear to you. So you got all the points related to electric current. So maximum this point only, these points only they will ask in the exam. So generally they will ask a few more points related to electric current. They will ask questions related to electric current. That is nothing but I equal to q by t related to quantization of charge, they will ask questions. And one more point, we can go with the one more topic, that is uh, potential difference and electrical potential. Related to that one, they will ask questions. And related to Joule's law of heating, that is nothing but heating effect of electric current. Resistors are in series, resistors are in parallel. Resistors are in series, resistors are in parallel. And resistors are in series, resistors are in parallel. And next one, based on factor depends on resistance. Factor depends on resistance also, they will ask questions. And that's enough. And coming to the electricity bill, to finding the electricity bill also, they will ask questions. So related to this chapter, these are the questions. These are questions are very, very important. So practice will do problems also. Problems I'll explain. Okay, so afternoon, around 3 o'clock. Okay, 3 o'clock I'll start the class. So 3 to 5, and again 6, and next after that 9. Like that I will discuss. So if you have any concerns, if you have any doubts, you can let me know. So this is your Siva sir signing off. Thank you.